Alright, so yesterday we looked at writing equations of parabolas in vertex and intercept form based off of given information like vertexes, intercepts, other points on our parabola. Today we're going to look at the same idea but in standard form. So what we're going to be given is a table of data. And for that table, the first thing we want to decide is if it actually is quadratic, if a parabola would be a good model for it. If it is, then we'll write that quadratic formula in standard form. Sometimes we may get some that are linear, though. So that's kind of the two we'll be looking at today, linear or quadratic. So to figure out which it is here, we're going to analyze the differences in the outputs to determine whether the data are linear, quadratic, or neither. If it's linear or quadratic, we're going to write an equation. So the way we do this, so when they say analyze the differences in outputs, we're going to look at the y values. So I want to know the difference between 424 and 416. So when I subtract those two, I get 8. When I do 416 minus 376, I get 40. 376 minus 304 is 72. 304 minus 200 is 104. And 200 minus 64 is 136. So this row here we call the first differences. If those first differences are all the same, we say that it's linear. Our first differences, of course, are not the same here, so I want to keep subtracting. So now, if I do 8 minus 40, I would get negative 32. 40 minus 72, negative 32. 72 minus 104, negative 32. And 104 minus 136, negative 32. We call this row the second differences. So what this means, since those are all the same, is that this is quadratic. So if you're asked on a test to show whether it's linear or quadratic and how do you know, I'm going to say quadratic because the second differences are all the same. So now the tricky part, or kind of the longer part here, is writing the equation. So yesterday when we were doing vertex form or intercept form, we really only needed 1 point on the parabola. This time we need 3. If you'll remember, standard form is this guy. And we now need to find values for A, B, and C. So we're going to start kind of the same way we did yesterday. So I'm going to pick a point. So I kind of like the one that has the smallest numbers. You really could pick anyone. So 64 is my y and 6 is my x. So I'm going to write an equation using that. So I have 64 equals, let's see, if x is 6, this would be 36a plus 6b plus c. And I'm going to call that equation number 1. So that's not enough to find my a, b, or c here. I need more equations. So I'm going to pick a second point. Well, I'm just going to pick 5 and 200. Really, you could pick any of them. And the same idea. So this is my second equation. 200 is y. 5 squared is 25a. 5b plus c. And then I need one more point. I'll pick this one here. So 304 equals 16a plus 4b plus c. So now this is actually something we have done before. We did this in chapter 1 and you guys are pretty good at this. So we're solving this 3-variable system to find what A, B, and C are. So those are my 3 variables. What's kind of nice about these is you always end up with that plus C on the end for all of them. So that's kind of our easiest variable to eliminate here. So I'm going to take equation number 1 and I'm going to multiply every piece by a negative 1. And then I'm going to take equation number 2 also and just rewrite that one as it is. So what works nicely here is those c's go away, which is what we want. We want one of our variables to go away. So I have 136 is negative 11a minus b. So I'm going to call that equation number 4 and let that be for a second. I'm going to do the same idea with equations 2 and 3. So I'm going to take equation number 2 and multiply everything by a negative 1. And then equation number 3. leave that one just as it is. So again, we notice our C's cancel out, and we end up with 104 equals negative 9a minus a b. So we call this equation number 5. So we've done this before. The only thing that's new here is how we set up the three equations. Solving them is exactly the same though. Next step here, then I have equation 4 and 5, and I want to eliminate a variable. So it's very close to being able to eliminate b without doing anything, but we just have to make one of those b's positive. So I'm going to take equation number 5 and multiply everything by negative 1. So negative 104 equals 9a plus b. And then equation number 4, just leave it as is. So now my b's cancel, and I'm left with 32 equals negative 2a. Divide each side by negative 2. So a is negative 16. Okay, so I'm almost there. I found a. Next, to find b, I want to plug into either 4 or 5, doesn't matter which one. So I'll take 4. And I have 136 equals negative 11 times negative 16, because I now know that's what a is, minus b. So 136 equals 176 minus b. So negative 40 is b, or negative 40 is negative b, so b is 40. There we go. So almost there, I have a, b. Now to find c, I have to go back to one of my original equations, so either 1, 2, or 3, because I need an equation that connects all three of my variables. So I'll pick 1 here. So I have 64 equals 36 times negative 16, plus 6 times I know b is 40, plus c. So I have 64 equals negative 336 when we simplify this, plus c. So c is 400. So my very final step is going to be to write my equation. So I have y equals a is negative 16 x squared, plus I know b is 40, plus my c, 400. So this would be my final answer here. All right, let's look at the next one. So same idea, I got to first decide what it is that we're working with here. So I'm going to look at the differences. So I'm going to do all of this subtracting. So 36 minus 30, 30 minus 24, and so on. And we can see they're all 6. So remember, those are called the first differences. It's my first row of differences. And since those are all the same, we say this is linear. So what's nice about linear is that makes it much, much easier. So linear means I want something in the form y equals mx plus b. I just need to figure out what m and b are. So to figure out m, I want my slope formula. So they give me 6 points there. I could pick any 2. So I'll probably pick these first 2 here just to keep it simple. So I'm going to do 36 minus 30 over 0 minus 3. So 6 over negative 3. Where my slope is negative 2. Now the y-intercept I can see right here when x is 0, y is 36. So b is 36. So my final equation is y equals negative 2x plus 36. So the only time we have to set up that system is if it is indeed quadratic. So this one was linear, so I just need to solve for y equals mx plus b. So look at the next one then. So I want to start by looking at my differences. So 5 minus 15 is negative 10. Here we get a negative 30. Here we get a negative 90. Here we get a negative 270. And a negative 810. Okay. So first differences are not the same. We got to keep going. Looking at the next one. So I have negative 10 minus a negative 30. So really that's negative 10 plus 30. Let's think about that. So being 20. This one then 60, 180, 540. Okay. So my first differences are not the same, so it can't be linear. My second differences are not the same, can't be quadratic. So this one is just a big neither, which is kind of nice when that happens because there's no more work to do other than that. Let's look at the last one here. So if you're feeling pretty confident with this, maybe pause and try this one on your own and come back and see how you did. So looking at my differences, I get 21, 15, 9, and 3. So it can't be linear. Looking at my second differences, all three of them are 6. So I know this guy is quadratic. So now I want to set up my system. So I'm going to pick that first point there. So I have y equals, so if my x is 1, 1 squared is just 1. It's just going to be a plus b plus c. Equation number 2 then, I'll go with the next point. So 60 equals 4a plus 2b plus c. 3 then, I'll pick that third point. Okay, so I've got my 3 equations here. So I'm going to eliminate c first. So I'm going to pick equations 1 and 2. Equation 1, I'm going to multiply by everything by a -1. So that leaves me with 21 equals 3a plus b. And this is my equation number 4. So I'm going to do the same thing to find equation number 5. This time I'm going to use 1 and 3, and I'm going to multiply equation number 1 by a -1 again. Equation number 2 I'll leave, or not 2, excuse me, 3. So my c's go away, and I'm left with 36 equals 8a plus 2b. So this is equation number 5. All right, then I'm going to combine 4 and 5 together, and I'm pretty close to being able to eliminate b. I'm going to multiply equation number 4 by -2, though. So that would give me -42 equals -6a minus 2b. 5 will stay just as it is. So I can see my b's will eliminate, and I'm left with -6 equals 2a, where a is -3. So that's always the hardest part, finding my first variable. I'm going to plug into equation number 4 then to figure out what b is. So 4 was 21 equals 3 times a is -3 plus b. So we have 21 equals -9 plus b. So b is 30. My last thing to do then is plug into one of my original 3 to find c. So I'll pick number 1. So we have 39. A is -3. B is 30 plus c. So we get 12 for c. So then my final answer, I'm going to bring those all together. So it's y equals ax squared plus bx plus c. So to kind of remind ourselves what we're doing here, I'm checking first and second differences. First differences mean linear. I need to write y equals mx plus b. Second differences mean I need to set up a system of equations, picking 3 points, and solve for a, b, and c.